How we can find out the inverse of a matrix. So today I give one more example how you can find out the inverse of the matrix. I will repeat the same procedure. See here. So this is a matrix. You have to find out the inverse of the matrix. Clear? So this one, any matrix A can be written as A equal to I into A. So I means identity matrix. So after we put the matrix, what is our first aim? We have to make this matrix, that means the matrix on the left hand side, to an identity matrix. So for doing that, at first our aim is you have to make this first column, first row matrix to an element 1. Okay. So now see here, this element is second row, first element is 1. So simply we interchange row 1 and row 2. We interchange row 1 and row 2 so that this element becomes equal to what? This element becomes equal to 1. Clear? So this is our first step. Always remember the first step is you have to make that element equal to, you have to make this element equal to 1. Clear? So in the next step, what happened? You have to make those elements equal to 0. That means the corresponding elements of the first column equal to 0. Okay. So how we can make this equal to 0? If 3 minus 3, it will becomes equal to 0. Okay. So that's why 3 minus 3 into 1. So we did R2 tends to R2 minus 3R1. R2 minus 3R1. So this 3 minus 3, it will be 0. 1 minus 3 to the 6 minus 5. 4 minus 3 into minus 5. So 4 plus 15, it will be 4 plus 15, it will be 19. So same operation you have to done on the right hand side also. Same operation you have to done on the right hand side also. Okay. So that is the first two step will always same. Okay, first two step will always remain same. First one you have to make this one equal to 1. Next, second step you have to make those elements equal to 0 by using row 1. Okay. Now say in the next step we can make this element equal to 1. So how we can make this equal to 1? If we add plus 6, this is minus 5. If we add plus 6, then this element equal to what? 1. At the same time, we can make this element equal to 0 by minus 2. Okay. So by using this row 3, we can make this element equal to 6 minus 5 plus 6, which is equal to 1, and 2 minus 2, which is equal to 0. So at the same step, see here what we have done. Row 2 tends to row 2 plus 6 row 3. Row 2 plus 6 row 3. So that this element becomes, see here, 0 minus 0 minus 0, it will be 0. Minus 5 plus 6, it will be 1. 19 plus 5 6 are 30. So it will be 49. And the next one is what? Row 1 tends to row 1 minus 2 row 3. Row 1 minus 2 row 3. So this element 2 minus 2 into 1. So 2 minus 2, it will be 0. Minus 5 minus 5 minus 5 minus 5 2s are 10. So it will be minus 15. Same operation we have done on the right hand side also. Now in the next step, see here, after making this one 0 and 1, we can easily make this element equal to what? 0. How we can make this one? 1 minus 1 equal to 0. This one is in row 2. So row 3 tends to row 3 minus row 2. So 0 minus 0, 0, 0 minus 1. 1 minus 1, 0. 5 minus 49, it will be minus 4. 5 minus 49, it will be minus 44. Same operation we done on the right hand side also. So now see next one, you have to make this equal to 1. So how you can make this element equal to 1? You have to multiply by minus 1 by 44. Okay, we have to multiply it by minus 1 by 44 so that this element becomes equal to 1. Same operation we done on the right hand side also. So after making this equal to 1, we can easily make this one and this one equal to what? 0. Okay, make these elements and these elements equal to 0. Okay, so how we can make this? This row 1 tends to row 1 plus 15 row 3. That means 15 plus 15, it will becomes equal to what? 0. So it is 0. Again, how we can make this equal to 0? Row 2 minus 49 row 3. So that 49 into 1, it will becomes equal to what? 0. Okay, so now you got this left hand side matrix is an identity matrix. Now you this is the matrix B. So you got this from BA equal to I. Okay, BA equal to I. Okay, then what happened? A inverse is equal to B. Now from this here, we can take common 1 by 44. We can take common 1 by 44. So this is the matrix. Okay. So try this tree as a homework. Find the inverse of the matrix. I've given 3 problems. You try yourself. Okay. So if you got any problem, you can ask me and you can show this homework in the group also. Okay. So our next topic is rank of a matrix. It is very important how we can find the rank of a matrix. So to find out the rank of a matrix, at first we have to know what is the minor of an element of a matrix. Okay. Suppose we are going to find out the minor of 0. Okay. Minor of 0. So minor of 0 means what? Simply you have to exclude this entire row and entire column. Then what is left? 3 minus 5, 1, 1. This one, 3 minus 5, 1, 1. So this is called minor of an element of a matrix. Same way, if we are going to find out minor of minus 4, then you have to exclude this corresponding row and corresponding column. What is left now? 3 minus 5, 1, 2. 3 minus 5, 1, 2. Okay, same way, suppose we are going to find out the minor of 3, then you have to exclude that corresponding row and corresponding column. Then what is left? 0, 2, minus 4, 1. Okay, 0, 2, minus 4, 1. Okay, that will be my minor of 3. Now, if I asked you what is the minor of minus 5, can anybody tell me? Anyone? What is minor of minus 5 in this case? Anyone?
0, 1, minus 4, 1.
Yeah, it is 0, 0, 1, minus 4, 1. Okay, so that is called minor of an element of a matrix. Now come to the point rank of a matrix. Rank of a matrix. Okay, see here. The rank of a matrix is said to be R if it has at least one non-zero minor of order R. Okay, if it has at least one non-zero minor of order R. Second step is what? Every minor of A of order higher than R is 0. Every minor of A of order higher than R is 0. So come to here. See here. Suppose this is a matrix. Okay. Suppose this is a matrix. Clear? Now from here, what you got? What is minor of 0? If you find the determinant of this, what you got? 3 ones are 3 minus 1 into minus 5. So 3 plus 5 it equal to 8. 3 plus 5 is equal to 8, which is not equal to 0. Clear? That means you got a minor of order 2 which is not equal to 0. Clear? That means the rank of the matrix is minimum 2. Rank of the matrix is minimum 2. From here we got this one. Now come to the point. It has at least one non-zero minor of order R. You got one non-zero minor of order 2. Now second step is what? Every minor of A of order higher than R is 0. So here order is 2. What is order 3? Order 3 means what? In this case, the whole matrix. Okay. Order 3 means in this case, the whole matrix. Now, if the determinant of the matrix is equal to 0, okay, listen it carefully. If the determinant of this matrix is 0, then rank of the matrix is equal to 2. Because we got a minor of order 2 which is not equal to 0. Now, if the rank of the matrix is not equal to 0, we can say that the rank of the matrix is equal to 3. Clear? I repeat once again. First condition is what? It has at least one non-zero minor of order R. So we already find out one non-zero minor of order R, minimum one. It can be more than one, no problem. We already find out this one where this determinant is not equal to 0. And the second one is every minor of A of order higher than R is 0. So higher than R, here order is 2. So more than 2 means it is what? 3. So 3 means the whole entire matrix. Now simply we have to find out the determinant of the matrix. Okay. Now if the determinant is equal to 0, then rank of the matrix is equal to 2. And if the determinant not equal to 0, if this determinant not equal to 0, then the rank of the matrix is equal to 3. Okay. If the determinant is not equal to 2, so not equal to 0, then the rank of the matrix is equal to 3. So listen it carefully. Rank of a matrix is same as the order of the matrix. Rank of a matrix is same as the order of the matrix if the matrix is a non-singular matrix. Remember these things. Rank of a matrix is equal to the order of the matrix if the matrix is a non-singular matrix. Okay. Now, what is a non-singular matrix? I have already told you. Non-singular matrix means what? Determinant is not equal to 0. Determinant is not equal to 0. Then rank of the matrix is same as the order of the matrix. Now, if the determinant of the matrix is equal to 0 means it is a singular matrix, then we have to find out the minor of the elements of the matrix. Now, if you get at least one minor not equal to 0, then you will get rank of, that will be the rank of the matrix. Okay. Now, there is one more way how we can find out the rank of a matrix. There is one more way how we can find out the rank of a matrix. So, rank of a matrix by triangular form. Okay. So, what is a triangle? At first, you have to know what is a triangular matrix. Suppose this is a matrix, clear, square matrix. In case of triangle, what happened? This is the diagonal. Okay, this is the diagonal. So what is an upper triangular matrix? So a upper triangular matrix is a matrix where, or a square matrix is called an upper triangular matrix if all the elements below the diagonal are equal to 0. Okay, upper triangular means what? If all the elements below the diagonal are equal to 0. Now see here, this is a square matrix. So I think you know this one. This is the diagonal. What is the diagonal? 1, 1, 3. Now see here, all the elements below the diagonal are equal to what? 0. And listen, there may be some 0 elements above the diagonal also. There's no problem. Only condition is what? All the elements below this diagonal must be equal to 0. Okay, that is called upper triangular matrix. Now, what is a lower triangular matrix? If all the elements above the diagonal are equal to 0, then it is called a lower triangular matrix. Okay, because in the lower half there is non-zero element. If all the elements above the diagonal are equal to 0, then it is called a lower triangular matrix. Now see here, what is rank of a matrix in case of triangular form? Okay, so here rank is equal to number of non-zero row in upper triangular matrix. What is called a non-zero row? Non-zero row means what? If all the elements in a row not equal to 0. Okay, if that is called non-zero row. If all the elements in a row not equal to 0, then it is called what? Non-zero row. Now see here, find the rank of the matrix. So this is a matrix of order 3 by 4. So this one. So same thing happen here also as we do in case of inverse of a matrix. So here our first aim is we have to make this element equal to 1. So in this case, it is already 1. So there's no problem because it is already 1. So our next step is we have to make those elements equal to 0. We have to make those elements equal to 0. Clear? So how we can make those elements equal to 0? Simply row 2 tends to row 2 minus 2 row 1. Row 2 minus 2 row 1. Okay, so this is 2 minus 2 minus 2 into 1. So 2 minus 2, which is equal to 0. And 1 row 2 minus 2, which is equal to 0. This 3 minus 2, which is equal to minus 1. 5 minus 3. Again, 5 minus 6, which is equal to minus 1. 1 minus 2 to the 4, so which is equal to minus 3. So next, row 3 tends to row 3 minus row 1. So 1 minus 1, which is 0. 3 minus 2, which is equal to 1. 4 minus 3, which is equal to 1. 5 minus 2, which is equal to 3. Now see here, these elements of second row and second row and third row are of same magnitude but different in sign. So if we add this one, okay, if you add row 3 tends to row 3 plus row 2, row 3 tends to row 3 plus row 2, then what happened? 0 plus 0, it will be 0. 1 plus minus 1, it will be 0. 1 plus minus 1, it will be 0. Again, this is also equal to what? 0. Now we can see how many non-zero rows are there. 2 non-zero rows. Now before this, you have to check whether it is possible to make all the elements of any other row equal to 0. Now tell me, can we make this elements of second row equal to 0, all the elements equal to 0? It is not possible, because if you want to make this one equal to 0, then this again not equal to 0. So it is not possible. So how many non-zero rows are there? 2 non-zero rows are there. This is not a non-zero row because all the elements of these rows are equal to 0. So there are 2 non-zero rows. So rank of the matrix is equal to what in this case? 2. Now see here one more example. This is 2, 3, minus 1, minus 1. So 1, minus 1, minus 2, 4, minus 4, this is given. I already told you what is our first time. We have to make this element equal to 1. So that's why we interchange row 1 to row 2 and row 2 to row 1 to row 2 and row 2 to row 1. So in place of row 1 we put row 2, 1, minus 1, minus 2, minus 4, and in place of row 2 we put this one row 1, 2, 3, minus 1, minus 1. Okay, so now our next aim is we have to make those 3 elements equal to 0. We have to make those 3 elements equal to 0. So how we can make this equal to 0? 2 minus 2, which is equal to 0. That means row 2 tends to row 2 minus 2 row 1. So what you got? 2 minus 2, it is 0. 3 minus minus 2, so it will be 5. Minus 1, minus 2 into minus 2, so minus 1 plus 4, it will be 3. And same way minus 1 plus 8, it will be 7. So next row 3 tends to row 3 minus 3 row 1. So 3, why we multiply by 3? Because we know this is 3 minus 3 into 1 equal to 0. So that's why row 3 tends to row 3 minus 3 row 1. Simply 3 minus 3 is 0. 1 plus 3, it will be 4. 3 plus 6, it will be 9. Again minus 2 plus 12, it will be 10. Clear? Next, row 4 tends to row 4 minus 6 row 1. Same way we minus this one, we got this 0, 9, 12, 17. Okay, now see here. After this, you maybe think that it is not possible to make all the elements of some row equal to 0. But you have to use the fraction also here. See, by looking this, we can say that it is not possible to make some row equal to 0. But we have to check it proper way. Okay, we have to check it proper way. See here, we can make this and this element equal to 0. How? By using row 2. So how we make this equal to 0? See here, row 3 tends to row 3 minus 4 by 5, row 2. That means 4 minus 4 by 5. 4 by 5 means 5 will be cancelled. So what is left? 4 minus 4, which is equal to 0. So after calculating this one, we got this is 33 by 5 and this is equal to 22 by 5. Okay. Same way, how you get this row 4? Row 4, same way row 4 minus 9 by 5, row 2. Same way, if you calculate this one, we got this 0, 0, 33 by 5, 22 by 5. Okay, so now see here, these two rows are what? Same. So if row 4 minus row 3, what you got? We got all the elements of this row equal to what? 0. Now you can check yourself. It is not possible to make these elements equal to, make all the elements of any row equal to 0. Okay, so that's why minimum rank, minimum non-zero rows is how much? 3. Therefore, in this case, rank of the matrix is equal to, rank of the matrix is equal to what? 3. Now see, it is in the triangular form. It is in the triangular form. So that's why, see, you can see here all the elements below the diagonal is equal to 0. Okay, all the elements below the diagonal is equal to 0. Okay, one thing you have to remember, this form is also called as echelon form. You can note down this echelon form, that means ECHELON. You can note down this one. This form is also called echelon form. ECHELON, echelon form. So in this way we can find out the rank of a matrix by using triangular method, okay, or echelon form. Now you tell me, what is the rank of a matrix? What is the rank of a non-singular matrix? Anyone tell me? What is the rank of a non-singular matrix? Kaushik, tell me, what is the rank of a non-singular matrix? It may be wrong also, no problem. Simply anyone tell me, what is the rank of a non-singular matrix? Barsa, tell me, what is the rank of a non-singular matrix? Yeah, it can be wrong also, no problem. I will repeat once again then. Anyone tell me, what is the rank of a non-singular matrix? Okay, then tell me, what is a non-singular matrix? Okay then. So I repeat once again. What is a singular matrix? Singular matrix means what? If the determinant of a matrix is equal to 0, then the matrix is called what? Singular matrix. And what is a non-singular matrix? If the determinant of a matrix is not equal to 0, then the matrix is called what? Non-singular matrix. Then the matrix is called non-singular matrix. Okay, and rank of a matrix of a non-singular matrix, okay, rank of a non-singular matrix is same as the order of the matrix. Always remember, rank of a non-singular matrix is same as the order of the matrix. Now you tell me, if the order of a matrix, order of a non-singular matrix is 4, what is the rank of the matrix? If the order of a non-singular matrix is 4, then what is the rank of the matrix? Anyone?
3, sir.
No, just listen to me carefully. If the order of a non-singular matrix is 4, not 3, 4, then what is the rank of the matrix? It is 4. Listen to me carefully.
4.
The order of a non-singular, the rank of a non-singular matrix is same as the order of the matrix. The rank of a non-singular matrix is same as the order of the matrix. Clear? So if the order of the matrix is 5 and the matrix is non-singular, then its rank is same. Rank is 5. Okay. We have to use this method, that means by use minor or by making the matrix to triangular form only in case of singular matrix, not in case of non-singular matrix. Okay. So there is one more method that is called normal form. Okay, how we can find out the rank of a matrix by using normal form, that we will discuss in the next class. Okay. Okay, then try this 3 as a homework and try this 3 question as a homework and give it to our group or give it to me personally also. Okay, no problem. Okay, then that's all for today. You just give your attendance in the group.